The Oldsmobile V8 refers to a series of Oldsmobile engines beginning with the advanced 1949 Rocket, the first post-war OHV V8 at General Motors. Like Pontiac, Olds continued building its own V8 engine family for decades, finally adopting the corporate Chevrolet 350 small block and Cadillac Northstar engine only in the 1990s. All Oldsmobile V8s were manufactured at plants in Lansing, Michigan. All Oldsmobile V8s use a 90-degree bank angle, and most share a common stroke dimension, 3.4375 in for early rockets, 3.6875 in for later Generation 1 engines, and 3.385 in for Generation 2 starting in 1964. The 260 cubic inches, 307 cubic inches, 330 cubic inches, 350 cubic inches and 403 cubic inches engines are commonly called small blocks. 400 cubic inches, 425 cubic inches, and 455 cubic inches V8s have a higher deck height versus 9.33 in, to accommodate a 4.25 in stroke crank to increase displacement. These taller deck models are commonly called big blocks, and are 1 in taller and 1.5 in wider than their small block counterparts. The Rocket V8 was the subject of many firsts and lasts in the automotive industry. It was the first mass-produced OHV V8 in 1949, and was the last carbureted V8 passenger car engine in 1990. The factory painted small blocks gold or blue, while big blocks could be red, green, blue, or bronze. As is the case with all pre-1972 American passenger car engines, published horsepower and torque figures for those years were SA gross, as opposed to 1972 and later SA net ratings. Generation 1, the first generation of Oldsmobile V8s ranged from 1949 to 1964. Each engine in this generation is quite similar with the same size block and heads. 303 . The 303 cubic inch engine had hydraulic lifters, an over-square bore, stroke ratio, a counterweighted forged crankshaft, aluminum pistons, floating wrist pins, and a dual-plane intake manifold. The 303 was produced from 1949 to 1953. Bore was 3.75 in and stroke was 3.4375 in. Cadillac used a distantly related engine which appeared in 3 different sizes through to the 1962 model year. Though the Oldsmobile and Cadillac motors were not physically related, many lessons learned by one division were incorporated into the other's design, and the result were 2 engines known for their excellent power-to-weight ratio, fuel economy, and smooth, strong, reliable running. The original Oldsmobile V8 was to have been marketed as Kettering Power after Chief Engineer Charles Kettering, but company policy prohibited the use of his name. Instead, the legendary Rocket was born, available in Oldsmobile's 88, Super 88, and 98 models. The engine proved so popular, base 88 models acquired the nickname Rocket 88. The 303 was available from 1949 through 1953. 1949 through 1951 88 303s came with a 2-barrel carburetor for 135 horsepower and 253 lb-aft. 1952 88 and Super 88 V8s used a 4-barrel carburetor for 160 horsepower and 265 lb-aft, while 1953 versions upped the compression from 7.51 to 8.01 for 165 horsepower and 275 lb-aft. For comparison, a 1949 Ford Flathead V8 produced just 100 horsepower. Applications: 1949 a Euro 1953 Oldsmobile 88, 1949 a Euro 1953 Oldsmobile 98, 1952 a Euro 1953 Oldsmobile Super 88. 324 . The 324 cubic inch version was also produced from 1954 until 1956. Bore was increased to 3.875 in and stroke remained the same at 3.4375 in. All high-performance 324s came with 4-barrel carburetors. The 324 was shared with GMC trucks. The 1954 88 and Super 88 V8s used an 8.25-to-1 compression ratio for 170 and 185 horsepower and 295 and 300 FTA pound-force respectively. The 1955 upped the compression to 8.51 for 185 horsepower and 320 lb-ft in the 88 and 202 horsepower and 332 lb-ft in the Super 88 and 98. For engines built during the first part of 1955, the 324 skirted pistons had a reputation for failing due to the cast aluminum skirt separating from its steel interior brace. This problem did not appear until the engine had over 50,000 miles on it. By late 1956, many Olds dealers learned about the problem. Compression was up again in 1956 for 230 horsepower and 340 lb-ft in the 88 and 240 horsepower and 350 lb-ft in the Super 88 and 98. Applications: 1954 Euro 1956 Oldsmobile 88, 1954 Euro 1956 Oldsmobile Super 88, 1954 Euro 1956 Oldsmobile 98. Equals 370 equals, a special 370 cubic inch variant called the 370 was used in GMC trucks alone, not shared. Equals 371 equals, making its debut in 1957 as standard equipment on all Olds models. The 371 was produced through 1960. Bore was now 4.0 in and stroke was increased to 3.6875 in for 371 cubic inches 1959 and 1963 71s used green painted valve covers. 4-barrel models used 9.251 compression in 1957 and 10.1 in 1958 for 277 horsepower and 400 lb-ft in 305 horsepower and 410 lb-ft respectively. A 1958 2-barrel version was still impressive at 265 horsepower and 390 lb-ft, but had problems with early camshaft failures due to the high preload valve spring forces. Then, power nosed downward for the 1959 and 1960 88 model, 270 horsepower and 390 lb-ft for 1959 and 240 horsepower and 375 lb-ft for 1960. It was no longer available in cars in 1961. The 371 was also used in GMC trucks and called a 370. Applications: 1957 a Euro 1960 Oldsmobile 88, 1957 a Euro 1958 Oldsmobile Super 88, 1957 a Euro 1958 Oldsmobile 98. J2 Golden Rocket, introduced in the middle of the 1957 model year. The 1957 and 1958 J2 Golden Rocket had three 2-barrel carburetors with a vacuum-operated linkage. Only the center carburetor was mechanically connected to the throttle pedal, and it was the only one equipped with a choke. When the center carburetor was opened to 60° or more, engine vacuum drawn from the windshield wiper pump would simultaneously open the front and rear carburetors. These carburetors did not open progressively. They were either open or closed. The J2 engine also had a slightly thinner head gasket, raising compression to 10.01. It was advertised with gross power and torque ratings of 312 horsepower at 4,600 rpms and 415 lb-ft at 2,800 rpms. Oldsmobile charged $83 for the J2 option with the 3-speed manual, $314 with the automatic. In practice, owners who did not regularly drive hard enough to engage the front and rear carburetors experienced problems with the linkage and carburetor throats becoming clogged, and some J2-equipped cars had the front and rear carburetors removed and blocked off. Moreover, correct tuning was a continual headache. The package was expensive to produce, and Oldsmobile discontinued it after 1958. 394 equals. Bore was up to 4.125 and for the largest first-generation rocket, the 394 cubic inches 394s were produced from 1959 a Euro 1964 and were available on many Olds models. Most 394s used 2-barrel carburetors. power was up to 315 horsepower, even though compression was down a quarter point, to 9.751. The 394 replaced the 371 in Super 88 and 98 cars for 1959 and 1960, and a detuned version was used in the 88 for 1961 and the Dynamic 88 for 1962 to 1964. Applications: 1959 a Euro 1960 Oldsmobile Super 88, 315 horsepower and 435 lb-ft. 1959 a Euro 1960 Oldsmobile 98, 315 horsepower and 435 lb-ft. 1961 Oldsmobile 88, 250 horsepower and 405 lb-ft. 1962 a Euro 1964 Oldsmobile Dynamic 88, 280 horsepower and 430 lb-ft. 1964 Oldsmobile Jetstar 1, 345 horsepower and 440 lb-ft. Skyrocket. The 1961 through 1963 Skyrocket was a 394 cubic inches engine. The 10-1 compression 1961 model produced 325 horsepower and 435 lb-ft, while the 10.251, 1962, 1964 version upped power to 330 horsepower and 440 lb-ft. A special 1963 10.51 version was also produced with 345 horsepower. Applications: 1961 a Euro 1963 Oldsmobile Dynamic 88, 1961 a Euro 1964 Oldsmobile Super 88, 1961 a Euro 1964 Oldsmobile 98. Starfire. The 1964 Starfire produced 345 horsepower and 440 lb-ft for the 1963-4 Starfire and 98 Custom Sports Coupe. It was optional on 1964 98s and Super 88s. Aluminum 215. From 1961 to 1963, Oldsmobile manufactured its own version of the Buick-designed, all-aluminum 215 engine for the F85 Compact. Known variously as the Rocket, Cutlass, and Turbo Rocket by Oldsmobile, it was a compact, lightweight engine measuring 28 inches long, 26 inches wide, and 27 in high, with a dry weight of only 320 pounds. The Oldsmobile engine was very similar to the Buick engine, but not identical. It had larger wedge, rather than hemispherical, shaped combustion chambers with flat-topped pistons, 6 bolts rather than 5 per cylinder, and slightly larger intake valves. The valves were actuated by shaft-mounted rocker arms like the Buick and Pontiac versions, but the shafts and rockers were unique to Oldsmobile. With an 8.75-to-1 compression ratio and a 2-barrel carburetor, the Olds 215 had the same rated HP, 155 horsepower at 4,800 RPMs, as the Buick 215, with 220 FTA pound-force of torque at 2,400 RPMs. With a 4-barrel carburetor and 10.251 compression, the Olds 215 made 185 horsepower at 4,800 RPMs and 230 lb-ft at 3,200 RPMs with a manual transmission. With a 4-barrel carburetor and 10.751 compression, the Olds 215 made 195 horsepower at 4,800 RPMs and 235 lb-ft at 3,200 RPMs with an automatic. The Buick version was rated at 200 horsepower with an 11-to-1 compression ratio. The Buick version of the 215 V8 went on to become the well-known Rover V8, which still remains in limited production, utilizing the Buick-style pistons, heads, and valve train gear. The Oldsmobile engine block formed the basis of the Refco 3-liter engine used by Brabham to win the 1966 and 1967 Formula One World Championships. The early Refco engines produced up to 300 bhp, and featured new SOHC cylinder heads and iron cylinder liners. The 1967 and later versions of the Refco engine had proprietary engine blocks. In the mid-1980s, hot rodders discovered the 215 could be stretched to as much as 305 cubic inches, using the Buick 300 crankshaft, new cylinder sleeves, and an assortment of non-GM parts. It could also be fitted with high-compression cylinder heads from the Morgan Plus 8. Using the 5-liter Rover block and crankshaft, a maximum displacement of 317.8 cubic inches is theoretically possible. Turbojet fire equals. In 1962 and 1963 Oldsmobile built a turbocharged version of the 215. The small-diameter Garrett T5 turbocharger with integral wastegate was manufactured by Garrett Research and produced a maximum of 5 psi boost at 2200 RPMs. The engine had 10.251 compression and a single-barrel carburetor. It was rated at 215 horsepower at 4600 RPMs and 300 lb-ft at 3200 RPMs. In development, the high compression ratio combined with the charged load created problems with spark knock on hard throttle applications, which led Olds to develop and utilize a novel water injection system that sprayed metered amounts of distilled water and methyl alcohol into the intake manifold airstream to cool the intake charge. If the fluid reservoir was empty, a complex double float and valve assembly in the turbo rocket fluid path would set a second butterfly into the closed position, limiting the amount of boost pressure. Unfortunately, many customers did not keep the reservoir filled, or had mechanical problems with the turbocharger system, which resulted in many of the turbocharger installations being removed and a conventional 4-barrel carburetor and manifold installed in its place. The turbocharger was offered only in a special Jetfire model, which was the second turbocharged passenger car offered for public sale. The Chevrolet Corvair Spider Turbo, also manufactured by GM, was ahead the Oldsmobile Jetfire Turbo by only a few weeks. Only 9,607 were sold in 2 model years, and many were converted by dealers to conventional 4-barrel carbureted form. Generation 2. The second generation of Oldsmobile V8s was produced from 1964 to 1990. Most of these engines were very similar, using the same bore centers, although big block versions were produced with a 10.625 in deck height rather than 9.33 inches. Big block and diesel versions also used a larger 3.0 in instead of 2.5 in main bearing journal for increased strength. All Generation 2 small block Olds V8s used a stroke of 3.385 in. The big block engines initially used a forged crankshaft with a stroke of 3.975 inches for the 1965-1967 425 and 400 CID versions. Starting in 1968, both the 400 cubic inches and the 455 cubic inches big blocks used a stroke of 4.25 in, with crankshaft material changed to cast iron except in a few rare cases. These engines, while being a wedge head, had a unique combustion chamber that resulted from a valve angle of only 6 degree. This was much flatter than the 23 degree of the small block Chevrolet and 20 degree of the Ford's small block wedge heads. This very open and flat chamber was fuel efficient and had lower than average emissions output. It was the only GM engine to meet U.S. emission standards using a carburetor all the way up to 1990. 330 The first second-generation Olds V8 to be released was the 1964 330 cubic inches, which Olds called the Jetfire Rocket. It was released 1 year earlier than the tall-deck 425 and introduced the standard 3.385 in stroke and used a 3.938 in bore and was produced through 1967. 330s were painted gold and had forged steel crankshafts. While the 4-barrel versions had a larger diameter harmonic damper, the 2-barrel versions used only a balancer hub without the rubberized outer ring. 400 The 400 cubic inches version was the second tall-deck big block Olds. 2 distinct versions of the 400 CID engine were made. 1965 to 1967 early 400s used a slightly over square 4.000 in bore and 3.975 in stroke for an overall displacement of 399.6 cubic inches. All the pre-1968 engines used a forged steel crankshaft. 1968 and 1969 400s shared the Olds big block standard 4.25 in stroke with the 455 but used a very undersquare 3.87 in bore to comply with GM's displacement restrictions in the A-body cars while also reducing tooling costs. Displacement is very close to the earlier engine, at 399.9 cubic inches. This later 400 is considered less desirable by many enthusiasts, because of the power band characteristics induced by this exceedingly under-square format, although the actual change in power was due to the mild 250/264 duration cam used in this engine and the fact that the crankshafts were now made of less durable high-nodular iron material. Early 400s used the same forged steel crankshaft as the 425, while later 400s used the same cast iron crankshaft as the 455, with rare exceptions. Some 1968 and later Olds 400-455s were produced with forged steel crankshafts. These rare cranks can be readily spotted by the J-shaped notch in the OD of the rear flange. Cast iron cranks have a C-shaped notch. All 1965 to 1969 Olds 400s were painted bronze. 4-4-2 rocket. The 1967 4-4-2 rocket was a 400 cubic inches V8. 425 equals. The 425 cubic inches big block was the first tall-deck big block, produced from 1965 through 1967. It is arguably the best engine Olds made in the muscle car era, although it never made it into a muscle car. It used a 4.126 in bore and 3.975 in stroke. Most 425s were painted red, though the 1966 and 1967 Tornado units were light blue. All 425 engines were fitted with forged steel crankshafts with harmonic balancers. Super Rocket, the standard 1965-1967 425 cubic inches was called the Super Rocket, and was the most powerful engine option for the Oldsmobile 88 and 98 of 1965 to 1967. Compression ratios of 9.01 at 310 horsepower or 10.251 at 360 horsepower were available in the U.S. Starfire, a special 1965-1967 425 cubic inches V8 was the Starfire engine. The main distinguishing features of this engine were a slightly different camshaft profile from the standard ultra-high compression engine and factory dual exhaust. This engine was only available in the Oldsmobile Starfire. It shared the same compression ratio of the Tornado rocket at 10.51. It also used the .921 in lifter bore size of the Tornado rocket. Tornado rocket, an ultra-high compression Tornado rocket version of the 425 cubic inches V8 was made for the 1967 Tornado. It had the same 0.921 in diameter lifters of the first-generation Oldsmobile engines, rather than the standard 0.842 in, which let engineers increase the camshaft's ramp speed for more power, 385 horsepower, without sacrificing idle or reliability. Unlike all other 425s, this version was painted slate blue metallic. 455 equals. A larger big block was introduced for 1968 as the Rocket 455 at 455 cubic inches to replace the 425s. It kept the 425's 4.126 in bore and bumped the stroke to 4.25 inches. Output ranged from 275 to 400 horsepower. Initially the paint was red, except in the Tornado applications, where they were painted metallic blue. 1970 to 1976 versions were metallic blue at first, then non-metallic blue. The rocket name disappeared from the air cleaner identification decal after 1974. Although production of the 455 ended in 1976, a small number were produced through 1978 for power equipment use. Applications: Oldsmobile Cutlass, Oldsmobile Vista Cruiser, Oldsmobile Custom Cruiser, Oldsmobile 4-4-2, Oldsmobile Delta 88, Oldsmobile 98, 1968 Euro 1970 Oldsmobile Tornado, 375 horsepower, 1968 Euro 1970 Oldsmobile Tornado GT, 400 horsepower, 1973 Euro 1976 GMC Motorhome. 350 equals, produced from 1968 Euro 1980, the Rocket 350 was entirely different from the other GM division's 350s. It used a 4.057 in bore on Oldsmobile small block standard 3.385 in stroke for 350 cubic inches. Output ranged from 160 to 325 horsepower. 1968-1974 350s were painted gold. 1975-1976 350s were metallic blue like the 455. 1977 to 1980 models were painted GM corporate blue. The rocket name disappeared from the air cleaner decal in 1975, the same year that the catalytic converter was added to the emission control systems. The early Oldsmobile 350s made from 1968 to 1976 are more desirable engines with heavy castings, beefier crankshafts, and better flowing heads. The later 1977-1980 350 had the lightweight castings, including a thinner block with large windows and the main bearing bulkheads, crack-prone head castings which were actually manufactured by Pontiac Motor Division, and a lightened crankshaft. The Oldsmobile 350 was produced with an analog electronic port fuel injection system, introduced in the Cadillac Seville of 1976. Applications: Cadillac Seville, Oldsmobile Cutlass, Oldsmobile Vista Cruiser, Oldsmobile 4-4-2, Oldsmobile Delta 88, Oldsmobile 98, Oldsmobile Tornado, Oldsmobile Amiga. L34, Oldsmobile Zone L34 350 cubic inch V8 was used in the 1979 Hurst Oldsmobile and 1984-4-2. The L34 used a 4-barrel carburetor and produced 170 horsepower and 275 FTA pound-force. 403 The 455 big block Olds V8 was replaced in 1977 with the 403 cubic inches small block V8. It used a wide 4.351 in bore, the largest ever used in a small block V8, with the old small block standard deck and 3.385 in stroke. The bore was so wide that the cylinder walls were Siamese. There was no space for coolant flow between the cylinders. This sometimes led to overheating problems. Some very early 403s were painted metallic blue like the 455, but most were painted GM corporate blue. The Olds 403 was used by Buick and Pontiac in addition to Oldsmobile. The engine was only produced through 1979. Output was 185 horsepower and 320 lb-ft. The Tornado version of the 1977 Oldsmobile 403 engine was fitted with a crank-triggered ignition system. Parts peculiar to this system include a toothed disc between the harmonic balancer and the crank pulley, the adjacent sensor, a special distributor, an engine temperature sensor, and a rudimentary computer mounted inside the car, under the dash. No other years or models were provided with this system. Applications: 1977 Buick Century Estate, 1977 Euro 1978 Buick Riviera, 1977 Euro 1979 Buick Electra, 1977 Euro 1979 Buick Estate Wagon, 1977 Euro 1979 Buick LeSabre, 1977 Oldsmobile Cutlass, 1977 Oldsmobile 4-4-2, 1977 Oldsmobile Vista Cruiser, 1977 Euro 1978 Oldsmobile Delta 88, 1977 Euro 1978 Oldsmobile Tornado, 1977 Euro 1979 Oldsmobile 98, 1977 Euro 1979 Oldsmobile Custom Cruiser, 1977 Pontiac Bonneville, 1977 to 1979 Pontiac Catalina Safari, 1977 Euro 1979 Pontiac Trans Am, 1977 Euro 1979 Pontiac Firebird Formula 6.6L, 1977 Pontiac Grand Prix available with California emissions only, 1977 Euro 1978 GMC Motorhome. 260 A smaller 260 cubic inches V8 was produced in 1975 by decreasing the bore to just 3.5 in. This was the first power plant to use the smaller Rochester Dialjet 2-barrel carburetor. All 260s used it. Production of the 260 V8 ended in 1982 when the 307 became the only gasoline V8 in Oldsmobile's line. The 260 was designed for economy and it was the first engine option above the 3.8L Buick V6 standard in many Oldsmobile models by the late 1970s. While the 260s were not very powerful compared to the larger 350 and 403 V8s, fuel economy was almost as good as the base V6. Compared to the V6, the 260 was also smoother running, and far more durable. Most 260s were coupled to the turbo-hydromatic 200. A 5-speed manual transmission was also available with some 260-equipped vehicles. Applications: 1975 a Euro 1977 Pontiac Ventura, Pontiac Le Mans, Oldsmobile Amiga, and Buick Skylark, 1975 a Euro 1982 Oldsmobile Cutlass, 1977 to 1982 Oldsmobile Delta 88. LV8. The LV8 was a 260 cubic inches version produced from 1975 to 1982. It produced just 105 horsepower and 205 lb-ft. Equals 307 equals. A slightly larger 307 cubic inches version was introduced in 1980. It uses a 3.8-in bore with a 3.385-in stroke. Some early 307s were painted GM Corporate Blue, but most were painted satin black. It was used in most Oldsmobile models, as well as those from Buick, Cadillac, Chevrolet, and Pontiac. Every 307 used a 4-barrel carburetor, generally a variant of the Rochester Quadrajet, usually the CCC Quadrajet. The output of the 307 cubic inches was not particularly high in terms of horsepower. For example, the stock 307 cubic inches in the 1983 Oldsmobile 98 was a mere 140 horsepower, although in that year a high-output model was available producing a nominal 180 horsepower, at approximately 245 lb-ft torque. The final 1990 configuration was rated at 140 horsepower at 3,200 rpms and 255 lb-ft of torque at 2,000 rpms. The combination of good lower PM torque, the Quadrajet 4-barrel carburetor, and the THM 200-4 a 3-speed plus overdrive automatic transmission having a lock-up torque converter allowed for fairly good performance, and fuel economy considered reasonable for the era, even in the larger and heavier model cars. Applications: 1980 a Euro 1985 Oldsmobile Delta 88, 1980 a Euro 1984 Oldsmobile 98, 1980 a Euro 1985 Oldsmobile Tornado, 1980 a Euro 1990 Oldsmobile Custom Cruiser, 1980 a Euro 1985 Buick LeSabre, 1980 a Euro 1984 Buick Electra, 1980 a Euro 1985 Buick Riviera, 1980 a Euro 1990 Buick Estate Wagon, 1986 a Euro 1987 Buick Regal, 1986 a Euro 1990 Chevrolet Caprice Wagon, 1986 a Euro 1987 Cadillac Brown Van 9, 1981 Pontiac Bonneville. LV2, Oldsmobile used the popular LV2, a 307 cubic inch engine, commonly known by the van code Y, from 1980 to 1990. It was used by every domestic GM automobile marque. Roller lifters, floating piston wrist pins, and swirl port intake runners were added in 1985. The 307Y produced 148 horsepower and 250 lb-ft in 1980 to 1984 models and 140 horsepower and 250 lb-ft in 1985 to 1990. All LV2s feature a 4-barrel carburetor. Y version applications: 1980 a Euro 1985 Buick LeSabre, 1980 a Euro 1985 Buick Riviera, 1986 a Euro 1987 Buick Regal, 1986 a Euro 1990 Chevrolet Caprice, 1980 a Euro 1985 Oldsmobile Delta 88, 1980 a Euro 1984 Oldsmobile 98, 1980 a Euro 1985 Oldsmobile Tornado, 1980 a Euro 1990 Oldsmobile Custom Cruiser, 1980 a Euro 1981 Oldsmobile Cutlass, 1982 Euro 1988 Oldsmobile Cutlass Supreme. 1982 Euro 1986 Pontiac Parisienne Van Y. 1988 Euro 1990 Cadillac Brown Van Y. LG8. The LG8 was a modern 307 cubic inches high output derivative of the LV2 produced from 1983 to 1987. Performance modifications included a hot camshaft, stiffer valve springs, a larger vibration damper, a wire-pipe dual-outlet exhaust system, and richer secondary metering rods in the carburetor. It was offered in the Hurst-Olds version of the Oldsmobile Cutlass Calais and in the 4-4-2 version of the Oldsmobile Cutlass Salon. Output for 1983 to 1985 was 180 horsepower and 245 lb-ft. Revisions to the engine for 1986 included roller lifters with a slightly smaller camshaft, new heads with smaller, swell port intake runners, floating piston pins, and larger piston dishes for lower compression. These changes increased torque to 250 lb-ft but lowered power to 170 horsepower, while lowering the RPM at which peak power and torque was achieved. Applications: 1983 Euro 1984 Hurst-Olds, 1985 Euro 1987 Oldsmobile 4-4-2, 1985 Euro 1988 Cadillac Brown Van 9. Generation 3. The Genii Oldsmobile V8 ended production in 1990. The company later introduced a new vehicle, the Oldsmobile Aurora, with a new generation of V8 power. Based on the Cadillac Northstar engine, the Oldsmobile Aurora engine was a DOHC design. See also, Oldsmobile Straight 6 engine, Oldsmobile Straight 8 engine, Oldsmobile diesel engine. From the 1950s through the late 1970s, each GM division had its own V8 engine family. Many were shared among other divisions, but each design was unique: Buick V8 engine, Cadillac V8 engine, Chevrolet small block engine, Chevrolet big block engine, Pontiac V8 engine, Holden V8 engine. GM later standardized on the later generations of the Chevrolet design: GM LT engine, Generation 2 small block, GM LS engine, Generation 3-4 small block. List of GM engines. External links: Oldsmobile engine FAQ. References: ABCDE Hot Rod, 3/86, pages 54. Flory, J. Kelly, Junior American Cars 1946–1959, pages 833. Flory, J. Kelly, Junior American Cars 1960–1972, pages 118. Flory, American Cars 1946–1959, pages 833. Flory, American Cars 1946–1959, pages 834. The optional heater defroster cost $85 that year, the optional base radio $96. Flory, American Cars 1946–1959, pages 834. Flory, American Cars 1946–1959, pages 990. Depending on carburation or use of turbocharger. Flory, J. Kelly, Junior American Cars 1960–1972, pages 205 and 246. Bechtel, John. Alternative Engines, Part 2, Buick V8. In Hot Rod Magazine, 11/84, pages 67. Bechtel, pages 67. Davis, Marlon. Affordable Aluminum V8s, Sick, in Hot Rod Magazine, March 1985, pages 84–9 and 121. Davis, pages 87.